Hello guys, welcome to another episode of GeeklyEDU. My name is Eddie, and today we will be talking about exponential functions. More specifically, about the derivative of exponential functions. Now, as we all know, exponential functions can look like this or like this. And we basically have a number which we call base, and that number is raised to a number or function which we call the exponent. Okay? Now, exponential functions are by far, I would say, one of the easiest types of functions to differentiate. Let's take a look at some examples. If I do the derivative with respect to x of e to the power of x, the solution is going to be e to the power of x. Okay? So what does that mean? That means that the derivative of an exponential function is the exponential function. Okay? As long as the base is e. Right? Now, this can definitely get more complicated if the exponent is a function and not just x. So for example, if I had a derivative of e to the 3x, then this would be e to the 3x times the derivative of the exponent, so times 3. Therefore, 3e3x. Okay? Now, let's do one more. Let's say that you have the derivative with respect to x of e to the, let's think of a crazy function. You have the tangent of 2x for some reason. So, as always, the derivative of the exponential function is the same. So that doesn't change. But now, in the exponent, we have a tangent. So we need to multiply by the derivative of the tangent, which is secant squared 2x. But then, we also have the 2x, which needs to be included. So there's going to be a 2 here. So the solution would be 2 secant squared 2x e tan 2x. Okay? And this can get as long and cumbersome as we want, but the idea is always the same. Okay? You first differentiate the exponential function. It's always the same. Then you start to deal with the exponent in case you have a function. You get this. And if within the exponent there's another thing, then you differentiate it again. Okay? And then you can see that in our first example, this is like if we had e to the power of x, which is e to the power of x times 1. Okay? Which is the derivative of the x, which is e to the power of x. So far, that's it. Very, very simple. Now, just to complicate it a tad more, what happens if the base is not e? What happens if you get the derivative with respect to x of, let's call it a to the power of x, where a can be any number? Well, in that case, and this is a little bit of a formula that you just need to memorize and, just use. This is going to be, again, you have the exponential function, but this time you're going to times it by the natural logarithm of the base. Okay? And if you think about it, this makes sense because natural logarithm of e is 1. So let's do here a side-by-side example. Okay? So if I have d dx of 3 to the power of x, and this is going to be 3x times the logarithm of 3. If on the other hand, again, following this rule, I do e to the power of x, then I have e to the power of x logarithm of e. But logarithm of e is 1, so this is just e to the power of x. What does that mean? That means that if you're going to remember one formula, this is the formula to remember. okay? Because this works for whatever base. Now, let's do a more complicated example. Let's say we have d dx of 3 to the power of 3x. It's exactly the same, guys. You keep the exponential function times the internal derivative, because there's a 3x here, so you have to multiply that by 3, times the natural log of 3, because that comes from the equation. So we get 3 natural log of 3 times 3 to the 3x. And that's it, guys. I hope that was clear. Again, this is it's very simple. You just gotta remember that when in doubt, usually the answer that you're gonna get when you take a derivative of an exponential function needs to look very, very similar to the actual exponential function. Okay, so it's not like when you take the derivative of a sine, you get a cosine, it looks different. No, if you have an exponential function in your response after you take the derivative, you need to have the same exponential function times maybe some other things. But the actual function needs to be there all the time, okay? And you can see it in all of our examples. So if it wasn't clear, if you have any questions, please leave a comment. We'll try to get back to you as soon as possible. Check out our channel. We're continuously putting out videos almost every single day. And, click that like button, subscribe, and I'll see you in the next one.